Lesson 19.1, Task 1, Probability Distribution. Construct Pascal's triangle. Pascal's triangle is a number pattern named after the French mathematician Blaise Pascal. The triangle is created by listing the total number of possible paths from the top of the triangle to each node on the triangle. Only downward movements are allowed. That is, each movement is either down to the left or down to the right. Pascal's triangle is shown. The triangle array on the left of the triangle shows the entries of Pascal's triangle using NCR. That's N combination R. N represents the row number and R represents the row position. Okay, so make sure you make a note of that. That is important. N represents the row and R represents the position in the row, starting with R equals 0. So what row 0 at the left? The value of NCR corresponds to the total number of different combinations of the left and right moves to reach each node from the top of the triangle. Okay, so Pascal's triangle is very easy to construct. It's very user-friendly, and it's not very hard. So you can see that down each side is all ones. And to construct Pascal's triangle, you just start with 1, and then these are always going to be 1s as well. And then you have a 1, and then you add 1 plus 1 is 2, and then put a 1 here. And 1 plus 2 is 3, 2 plus 1 is 3, 1's always down the diagonal. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then 1, and then you can make your triangle as large as you need depending on how many combinations you are looking at. So as you can see, they stop here with row 4, but again, it's very easy to construct. You just add 1 plus 5 is 6, 5 plus 10 is 15, 10 and 10 is 20, 15, 6, and 1. And you can, again, keep going as many rows as you need to. But that's how you construct Pascal's triangle. And again, make sure you know that R represents the row position and N represents the number of rows. So the top one is row 0, and you can see that each position here is position 0. So it's always going to have 0, 0 on the top here. All right, so let's see what we need to look at with Pascal's triangle. So it says, look closely at Pascal's triangle. What do you notice about the numbers running down the left and the right side of the triangle? Well, you notice that these are 1, okay? Each of the nodes along the left side is reached from the top position by always moving left. So it's going to be R equals 0, the number of times N indicated by the row number. Each of the nodes along the right side is reached from the top position by always moving right. Okay, when you move to the right, R equals N. And you can see this up here. This one's 1, 1, 2, 2, 3, 3, 4, 4. So your row and the position are going to be the same on the right side. All right, so this is the left side. It represents R equals 0. Here, these are all 0. And down here, the R equals the N. So that's what this indicates here. All right, so it says focus on the first 3 appearing in row 3. So row 1, 2, 3, the first 3 here. So this is position 0, so this would be position 1. So this represents 1, 2, row 3, position 1. So it says notice that the corresponding entry in the triangle array of the right of row 3 is 3 combination 1. What is the meaning of this notation? Explain how it corresponds to the 3 in Pascal's triangle. All right, 3 combination 1 represents the number of ways to reach a node by making a total of 3 moves, one of which is to the right. Each of these paths arrives at the first 3 in row 3 of Pascal's triangle. All right, so again, they're just trying to get you to think about what row 3 combination position 1 means to get to this position. 1, 2, 3, row 3, position 0, position 1, 2, 3. This would be row 3, position 3. So this is row 3, position 1. What does that 3 represent? 1 plus 2 equals 3. That's just the number of combinations that would occur. All right, so look at the 2 entries directly above the first 3 in row 3. All right, the 2 entries above, the 1 and the 2. How are these 3 numbers related? Is it true for all the interior numbers of the triangle? And the answer is yes. How are they related? 1 plus 2 is 3. 2 plus 1 is 3. 3 plus 3 is 6. 6 plus 4 is 10. So the 2 numbers above a number in a row are always going to be the sum, or this number will always be the sum of the 2 numbers above it. All right, so those are related. What combination of left and right moves takes you from the top of the triangle to the 6 in row 4? All right, row 1, 2, 3, 4. All right, so it says what combination of left and right movements take you to the top of the triangle to the 6 in row 4. How does corresponding NCR notation in the triangle array at the right above verify your position? All right, so that would be row 1, 2, 3, 4, position 2. Remember, we start with 0, 0, 1, 2. So row 4, position 2. So N is your row number, so it would be 4C2. 4C2 would be what we're looking for. So it says a combination of 2 moves. Let me write that down so I don't forget it. Okay, so the 6 in row 4, 1, 2, 3, 4. So this comes from your 4th row and your 2nd position, because again 0, 1, 2. All right, let's read the choices here. All right, so a combination of 2 moves with 4 moves to the right leads to the 6 in row 4. The corresponding NCR notation is 4 combination 2 verifies that total of 2 moves with 4 being at the right. Okay, so 4 is at the left, not the right. So a combination of 4 moves with 2 moves to the right leads to 6 in row 4, corresponding to NCR notation. 4 combination of 2 verifies a total of 4 moves with 2 being on the right. So that probably is the correct answer. A combination of 6 moves with 4 moves to the right and 2 moves to the left leads to 6 in row 4. The corresponding NCR notation in or 4 combination of 2 verifies a total of 6 moves with 2 being to the left. So the left here is not a 2, so that can't be it. A combination of 6 moves with 4 moves down and 2 moves to the right leads to the 6 in row 4. The corresponding NCR notation for combination 2 verifies a total of 4 moves down and 2 moves to the right. This one probably is the next closest one. So I don't know why this moves right. Combination of 6 moves with 4 moves down. Okay. We don't typically indicate this. Let's see if this is the correct answer. All right, so the second one is the correct answer. The fourth one there is a little tricky, but The second one is the better answer, and it says one such path is left, right, left, right. All right, so it just talks about the different combinations to get to this. All right, very quickly, I want to show you. Coming up, we will do some more examples of this, but if you want to see how 4 combination of 2 can be found using your calculator, if you turn it on, you have to put in the 4 first, and if you go to Math, and you scroll all the way over here to Probability, because that's what we're working on right now, and you do NCR, that's the notation we're using, and you do 4 combination of 2, it's going to also tell you what that number is in Pascal's triangle. So again, we will be looking at some more stuff using the calculator, but it's also a good idea to know how to make Pascal's triangle on your own. All right, that's all for task 1. If you have any questions, let me know.